It is the autumn of 1943, and somewhere over the flat, unremarkable fields of Sherburn in Elmet in Yorkshire, something is happening that defies every reasonable expectation of what a motor vehicle is supposed to do. A standard Willys MB Jeep, 4 wheels, a flat bonnet, a canvas top, roughly the same dimensions and weight as a family saloon, is airborne. Not merely being carried, not strapped beneath a transport aircraft. Airborne under its own rotary principle, spinning blades above it thrumming against the grey English sky, the whole improbable machine behaving against every instinct, like something that was always meant to fly. The pilot, wedged into the driver's seat with a set of controls no engineer would have designed if they had stopped to think about it for more than a moment, makes a gentle adjustment. The Jeep responds. It climbs. Approximately 30 meters below, the watching engineers exchange glances that contain, in equal measure, relief, disbelief, and a very particular strain of British pride that does not permit celebration until the thing has also landed safely. This is the Rotabuggy, or if you prefer the official designation, the Blitzbuggy, or if you prefer the name that nobody used officially, but which captures the essential spirit of the enterprise rather perfectly, the Flying Jeep. It is one of the most extraordinary vehicles the Second World War produced, not because it was the most lethal, or the most technically sophisticated, or even the most successful. It was, by most objective measures, somewhat absurd, but it flew. And the story of why Britain needed a flying Jeep, and how a small team of engineers managed to build one, tells you something essential about the nature of wartime ingenuity. That necessity has no patience for dignity. The war had been grinding forward for 4 years by the time the Rotabuggy made its first tentative hops into the Yorkshire air. 4 years during which every nation involved had been forced to confront the same fundamental problem of modern warfare. That you could drop men from the sky, but you could not drop the equipment they needed to fight with any reliability whatsoever. Paratroopers were light infantry by definition and by necessity. They carried what they could on their backs and hoped that whatever was waiting for them on the ground could be managed with rifles and grenades and courage. Against entrenched positions, against armored vehicles, against anything that required sustained firepower or motorized mobility, they were desperately vulnerable. The problem was not theoretical. The catastrophic Allied airborne operations of the early war years had demonstrated it with brutal clarity. Men dropped behind enemy lines found themselves isolated, under-equipped, unable to move fast enough to exploit whatever tactical advantage their surprise arrival might have created. The glider had offered one solution. You could pack a glider with supplies, with artillery pieces, with small vehicles. But gliders were slow, fragile, wildly susceptible to ground fire, and required a landing zone that the enemy would, if they had any sense at all, be watching carefully. Every glider that carried a Jeep to a drop zone was a glider that could not carry 20 men. The arithmetic was miserable. What was needed, and this is easier to state than to achieve, was a way to deliver a fully functional military vehicle directly into a combat zone from the air, with sufficient reliability that commanders could plan around it, rather than simply hoping for it. The Jeep had, by 1942, established itself as perhaps the single most indispensable vehicle the Allied forces possessed, lightweight enough to be hauled through mud that would swallow a lorry, powerful enough to mount a heavy machine gun, tow a light artillery piece, serve as a field ambulance, carry a radio station, or simply get 4 men across terrain that would defeat any civilian conveyance. If you could deliver jeeps directly into combat from the air, reliably and in quantity, you changed the nature of airborne warfare entirely. The question was how. The conventional answer, pack the jeep into a glider, had been tried and was being tried. It worked after a fashion, but it required a glider, a tow aircraft, a landing zone, and a great deal of luck. The unconventional answer came from a man named Raoul Hafner, and it was so unconventional that the first instinct of any sensible person encountering it was to assume that Hafner had misunderstood the problem. Hafner was Austrian by birth, an aeronautical engineer of considerable talent and rather extraordinary confidence, who had been working on rotary wing aircraft since the 1930s. He had come to Britain before the war, and when war came, he had brought with him the conviction that the autogyro, a rotary wing aircraft that used an unpowered rotor for lift and a conventional engine for forward thrust, was the key to solving the Army's airborne mobility problem. The autogyro had been around since the 1920s, and it had never quite managed to become either a practical military aircraft or a commercially viable civilian one. But Hafner was not deterred by the technology's history of near misses. He was working for the Airborne Forces Experimental Establishment at Sherburn in Elmet, and he had a proposal. The proposal was this: attach an autogyro rotor to a standard jeep, tow the resulting machine behind a transport aircraft, cut it loose over the drop zone, allow it to descend under the auto-rotating rotor, the same principle that allows a maple seed to fall in a spiral rather than dropping straight down, producing drag and a degree of controlled descent. Land the jeep in or near the target area. Drive away. The elegance of the concept was that it required no engine for flight. The rotor would spin freely as the machine descended, the airflow through it generating just enough lift to slow the descent to something survivable. The jeep's own engine was not used during the aerial phase at all. When the machine landed, you folded away the rotor assembly, started the engine, and drove. The jeep did not need to be modified in any fundamental mechanical sense. It was still a jeep. It just happened to also be, briefly, capable of something resembling flight. The engineering realities were considerably more complex than this description suggests. Hafner and his team at Sherburn in Elmet had to design a rotor system that could be attached to and detached from a standard Willys MB without requiring workshop facilities that a paratroop unit would not have in the field. The rotor itself had a diameter of approximately 14.6 meters. For scale, imagine the full width of a modest suburban semi-detached house spinning above the vehicle. It was 3-bladed, and the blades had to be capable of being folded for ground transport and then deployed in the field with minimal tools and training. The rotor hub was mounted on a pylon that attached to the jeep's frame immediately behind the front seats. This pylon had to be strong enough to take the aerodynamic loads of the rotor during descent without transferring forces to the jeep's chassis in ways that would tear it apart, while simultaneously being light enough that the overall addition to the vehicle's weight did not make the descent rate impossible to control. The total weight of the rotor assembly was approximately 181 kilograms, roughly equivalent to 2 well-equipped soldiers, which gives some sense of the balance that had to be maintained. The control system deserves particular attention because it was here that the true ingenuity and the true eccentricity of the Rotabuggy were most perfectly combined. The pilot And it is important to note that in the Rotabuggy, the pilot was also the driver, sitting in the normal driving position, controlled the vehicle's attitude during descent using a control column mounted in place of the normal driving controls. This column connected to the rotor head and allowed the pilot to tilt the rotor disc, which changed the direction and degree of lift, and thus the attitude of the machine during descent. The Jeep's steering wheel remained in place and would be used once the machine was on the ground. The tail unit, because even a flying Jeep needs a tail to maintain directional stability, consisted of twin fins and rudders mounted on a structure extending rearward from the Jeep's rear. This was perhaps the most visually striking addition to the vehicle, transforming the familiar rear end of the Willys MB into something that suggested, improbably, a small aircraft that had been grafted onto the back of a military vehicle by someone who had not entirely made up their mind about which it was supposed to be. Initial testing began in late 1942 with a scale model towed behind a motorcar on the ground to test the rotor system and control behavior before committing a full vehicle to the air. The results were sufficiently encouraging that Hafner's team proceeded to construct the full-scale prototype. The first vehicle used was a standard production Willys MB, and the construction of the full assembly was carried out at Sherburn in Elmet, with the practical directness that characterized most British experimental military projects of the era, which is to say, with limited resources, considerable improvisation, and a collective determination not to fail that substituted for several things money might otherwise have bought. If you are finding this story as extraordinary as it deserves to be found, a quick subscribe helps more than you know. Actual flight testing of the Rotabuggy began in November 1943. The vehicle was towed behind a Whitley bomber, which provides its own particular image. A heavy, rather ungainly aircraft that had already been largely superseded for frontline bombing duties, towing a Jeep with a rotor on top of it across the Yorkshire sky. The early tests were not entirely reassuring. The machine vibrated badly at certain airspeeds, and control was described by the test pilots as demanding rather than comfortable. One test report noted, with considerable British understatement, that the Rotabuggy was not entirely pleasant to fly. This is perhaps not surprising. The aerodynamic challenges of making a vehicle designed to be as practically unaerodynamic as possible, boxy, high-fronted, bristling with angular surfaces, behave acceptably in the air were considerable. The vehicle's body generated drag in ways that a purpose-built aircraft would never have had to accommodate, and the interaction between the rotor's aerodynamic behavior and the turbulent airflow around the Jeep's body was a source of continuous difficulty. Despite these challenges, the Rotabuggy demonstrated that the basic concept was viable. It flew. It could be controlled. It could be landed in a field without killing the pilot. Records of specific operational sorties conducted using the Rotabuggy are sparse, which is not unusual for experimental wartime projects at this stage of development. The vehicle was still under development and evaluation when the war's circumstances began to change in ways that would affect its future. Test flights continued through 1943 and into 1944, with the rotor and control systems undergoing progressive refinement. Whether it ever carried a military crew into an actual combat zone rather than a test pilot into a Yorkshire field is a question to which the available records do not provide a definitive answer. What can be said with confidence is that by the time the program was discontinued, the Rotabuggy had accumulated sufficient flight data to demonstrate that the concept was not merely theoretical. The German approach to the same problem of delivering vehicles aerially took different forms. The Wehrmacht had experimented with the Gotha Go 242 glider, and later the enormous Messerschmitt Me 321 Gigant for delivering heavy equipment and vehicles. But these were conventional gliders operating on the conventional principle of packing cargo into a large body. The Germans had not, so far as available records indicate, pursued the notion of giving the vehicle itself rotary lift. Their approach to airborne vehicle delivery remained tethered to the glider concept that Britain was simultaneously trying to supplement or replace. The American approach was similarly conventional in its attachment to gliders. The Waco CG-4A was the principal American cargo glider, capable of carrying a jeep or a small artillery piece, and it was a practical and reasonably reliable machine. But it shared the fundamental limitation of all gliders. It needed a landing zone, it was not reusable, and it was vulnerable to ground fire during its long, slow final approach. The Rotabuggy offered something qualitatively different, a vehicle that could descend almost vertically into a space too small for a glider, with a much reduced profile during the descent phase. The comparison that matters most is perhaps not with other nations' attempts to solve the same problem, but with the Rotabuggy's closest British relation, the Rotatute, a similar Hafner design that applied the same autogyro rotor principle to a single soldier rather than a vehicle. The Rotatute was a remarkable device in its own right, essentially a rotating wing parachute that allowed a soldier to descend more slowly and with greater directional control than a conventional parachute permitted. Both devices demonstrated Hafner's conviction that the autogyro principle had military applications that had not been fully explored, and both were ultimately overtaken by the same shift in strategic circumstances. The Rotabuggy program was cancelled in 1944. The official reason, and it is a reason that carries the weight of genuine strategic logic rather than mere bureaucratic caution, was that the development of improved glider designs, particularly the Hamilcar, which was large enough to carry a light tank, had advanced to the point where the jeep delivery problem was considered adequately solved by conventional means. The Hamilcar could carry 2 jeeps simultaneously, or a Tetrarch light tank, and it was entering service in sufficient numbers to make the case for an alternative delivery system considerably harder to argue. The resources invested in the Rotabuggy program were redirected. There is also a harder truth that the program's cancellation reflects. The Rotabuggy was a genuinely difficult machine to operate safely. The control demands it placed on its pilot were significant, and a pilot who was also supposed to be a military driver, capable of stepping out of the vehicle and immediately engaging in combat operations, faced a training burden that conventional glider crews did not. The program was not cancelled because the concept had failed. It was cancelled because a simpler solution had become available at roughly the moment when the simpler solution was most needed. The actual historical impact of the Rotabuggy is difficult to assess precisely because it never reached operational deployment. Its material contribution to the Allied victory is, in strict accounting, nil. No enemy position was taken because a flying jeep landed behind it. No supply line was cut, no bridge held, no reconnaissance mission completed that would not otherwise have been possible. But the program's significance is not best measured in operational outcomes, and measuring it that way misses something important. What the Rotabuggy represents is the willingness of British military research, under the pressure of wartime necessity, to pursue ideas that had no guarantee of success through a development process that required considerable investment of scarce resources. Hafner's team at Sherburne in Elmet did not have the luxury of iterating slowly on a concept over years of peacetime research. They had to make it work quickly with what they had, under the constant pressure of a war that would not wait for elegant solutions. That they produced a machine that actually flew, that actually demonstrated the concept was viable rather than merely theoretically interesting, is an achievement that the program's cancellation should not obscure. The legacy of the Rotabuggy is traceable most directly in the continued development of rotary wing aircraft for military use. Raoul Hafner himself went on to work on helicopter development after the war, and the principles he applied to the Rotabuggy, that a rotary wing could provide controlled descent for a vehicle that had no aerodynamic pretensions whatsoever, fed into the broader understanding of how rotary wing lift could be exploited in ways that fixed-wing aircraft could not replicate. The helicopter, which by the time of the Korean War was already transforming military logistics and casualty evacuation, owes something to the experimental tradition that the Rotabuggy represented. If you want to see what remains of the Rotabuggy program, you will find yourself looking at photographs and technical drawings rather than a preserved example. No complete Rotabuggy has survived to the present day, which is perhaps appropriate for a machine that existed at the intersection of the experimental and the operational without fully inhabiting either category. The Airborne Forces Museum and various archive collections hold the documentary record, and it is a record that repays attention for what it reveals about the texture of wartime ingenuity, the willingness to ask questions that begin with, "What if we just," and follow them through to their logical, improbable, airborne conclusions. Return then to that Yorkshire field in the autumn of 1943. The Jeep has climbed, has held its altitude, has demonstrated to the watching engineers that the absurd thing they have built is, within the limits of the term, actually flying. Now it descends. The rotor blades continue their autogyrational spin, and the machine comes down into the field with the controlled awkwardness of something that has no business being in the air at all and knows it. The undercarriage makes contact. The Jeep bounces once, settles, rolls to a stop. The pilot switches off the rotor. He opens the door, the standard Jeep door with its standard handle and its standard hinge, and steps out onto English grass. He looks back at the machine. There is the familiar boxy shape of the Willys MB, its flat bonnet, its canvas hood. There are the twin-tail fins extending rearward like an afterthought from a different machine entirely. And there, above it all, the rotor assembly slowly winding down, the blades tracing their last lazy circle before coming to rest. Someone, somewhere nearby, begins to clap. Others join in, not because the Rotabuggy was beautiful or elegant or even particularly pleasant to fly, but because it did the thing it was built to do, because a team of engineers, given an impossible problem and insufficient resources and no guarantee of success, had built a Jeep that could be towed through the air and set down in a field and driven away from. They had built it in Yorkshire in wartime with limited budget and enormous determination, and they had proved it could be done. The fact that it was never used in anger, that the war moved on before the flying Jeep could move with it, does not diminish that achievement. It merely places it in its proper category. The long list of things that British engineers did during the Second World War that nobody asked for. Everybody doubted, and only a very few people were ever able to explain to their satisfaction. It flew. That is the thing that matters. Against every expectation, in defiance of every sensible objection, the Jeep flew